Question 4, right? It says, given the state diagram for a down counter, complete the state table, write logic expression for the next state logic. Also, what type of D flip-flops are needed if you were to implement this down counter as a circuit? Draw it real quick.
So, VHDL. Still okay with the VHDL? Oh, can I say one more thing about the VHDL?
Of course you can.
So on the cover page of the test, he gives you entity, NAND gate, port, architecture. If you can't remember where to put signals and components, look at it right before the test, and as soon as you get the test, write it in. It's between architecture and begin. And then the port maps go between begin and end.
Where are you reading?
Is it different?
Yes, the beginning
Oh,
of
okay.
our test looks like.
Oh, okay.
He doesn't have any.
He doesn't give you anything. Okay. That's good.
You have to do a component.
Does he give you this?
Oh,
Yeah? Oh, okay.
I just.
Okay. Well, never mind. He gives you everything.
When do you gotta
What's
make
your
a component?
If your circuit, you're building this circuit
I don't have to memorize it.
with these inputs and these outputs, this block with these pins is described by the entity. Anything inside of this block is architecture. So the inside is architecture.
That's a symbol?
The symbol.
Yeah.
Yeah, so the entity basically describes what the symbol looks like, and then the architecture says how does this output get created from these inputs. Does that make sense? So if you have another block in here somewhere, so you have 3, whatever,
Could
whatever
be
the
a
block is.
component.
When you do a port map, you're saying, I want one of those things in my circuit, and then you have to wire it up however it needs to be. So that's the port map, this is how it's connected into my circuit. Does that make sense?
And you
Yeah.
use the names that are on like the wires, right?
Yeah.
Yeah.
Okay.
Okay.
Is that not clear to anybody? Like, when, like what the entity does, what the architecture does, what a port map does, the component. When you do component component before begin,
You'll give us the component, right?
usually you will, yeah.
Okay.
Yeah, because if you have to memorize the component too, eek, it's too much.
So whenever you do component, whatever, and then you say port, something, your inputs and outputs.
Darn it.
This component, not the port map, this component is just defining what this thing looks like. So it's like another entity, but for a different circuit. So that you can, we call it instantiating the component. When you do the port map, you're instantiating one component. And so after this, you do port maps in here.
And a way to be a end component. So it's
Writing the answers to the test to make sure what.
So the port maps go in here. And you can have however many other little circuits you want. As long as it knows what it looks like in this part, then you can define as many port maps here as you want. But you only need one of these things per circuit. Per, like, say this is a decoder or something. Then you just need one component definition for the decoder, and then you can have 20 port maps for a decoder. Does that make sense? This one just says it looks like this. Here you're saying I want one in my circuit, and this is how I connect it.
What if like, some list he gives us, for example, since add 3, we use add 1 as a component, right?
Mhm.
So how would you do like the add 3 in itself?
You'd have add 1, 0, add 1, 1, and add 1, 2,
Two.
right?
So
Like, what does that
this
mean?
is add 3, right?
Mm-hmm.
So you have add 1. Add 3 bits, is that what we mean?
I think so.
I think so.
Yeah.
Another add 1. And one more add 1. So your add 3 has these 3 inputs, and probably like, or maybe 4 inputs and 4 outputs. And then each of these has like 2 inputs, 2 outputs. So you're gonna have, when you say architecture, then you're gonna say component, add 1, and then you do the port for that, whatever the inputs and outputs are. And then you do, in the begin, you say I want add 1 for bit 1, add 1 for bit 2, and add 1 for bit 3. These are the names that I'm giving, and these are each add 1s. And the port map describes how they're connected.
Your port map entries should be in the exact same order your component port entries have been put in. So if your component add 1 port has A and B as inputs, and then C in or C out and S as your outputs, then your port map should follow the same thing. It should be A, then B, then C out, then S. They need to follow exactly, or it won't work. Okay?
Does that make sense where everything goes?
Yeah.
What each of them does?
So where do signals go, like,
Signals also go before.
between?
Yeah.
Yep, either before your component or right after your component, but
Doesn't matter.
between architecture and begin is where your component and your signal goes. They're interchangeable, whether signal goes first and then component, or whether component goes first and then your signal. But as long as it's between architecture and begin. Okay?
So this section here is kind of like you have your entity that describes inputs and outputs, or in-outs or whatever. This part is like, oh wait a minute, I need more wires, I need more other components that my circuit's built of. But the outside world doesn't have to see that stuff. That's why we put it in here. It's good.
Outside is just the
Entity.
port maps for the weekend.
For those circuits, yes. For your circuit, it's the entity part. Because if your circuit was going to be used in another circuit, then they'll do a port map using your entity. This thing.
It's like looking at your cell phone. Okay? The big entity is the cell phone itself. Okay? And then whenever you get into the components, that would be like your battery inside that you don't ever see, and like everything else. Your signals would be some of your wires. And then your architecture is how everything works inside, so you can have your output of just your phone. Does that make sense? Maybe something a little more visual that you can think on.
And the begin is how it's all connected.
Start. It's like, go. Talk to me. Tell me how this works.
Yeah, connections or logic.
Okay. Okay, let's try this other guy. Let me shut this guy off.